My name is Benny, and I've chosen for my chemistry vlog task the caffeine molecule. The reason I chose caffeine is because, like billions of people around the world, I consume it almost daily. I always wondered what the chemical makeup was of caffeine, so I thought, why not do it for my assignment and change the perception of a cup of coffee for me and you forever. Enjoy. Caffeine, also known as trimethylhexafine, has a chemical formula of C8H10N4O2, meaning it consists of 8 carbon atoms, 10 hydrogen atoms, 4 nitrogen atoms, and 2 oxygen atoms. All these atoms form together a naturally occurring organic compound that affects the human body by stimulating the nervous system and increasing alertness. So, what does the caffeine molecule look like, and what are the properties of it? Firstly, let's analyze the properties of this molecule. For one, the molecule is polar. Now, what does that mean, and why is it a polar molecule? Well, firstly, the polarity of a molecule is in fact very crucial to its properties. In caffeine's case, its bitterness, solubility, and melting point, which in fact is 235.3 degrees Celsius, and its famous aromatic smell all stem from its polarity. Now, caffeine is polar. This means the electrons are shared unequally and are closer to the more electron negative. Now, I've got here a water molecule. The reason I've shown you on the water molecule is because it's a bit too complicated to show on the caffeine molecule. As you can see, it is imbalanced. The electron activity is all on this side and the positive is all on this side. That's why it's polar. In case of caffeine, the oxygen and nitrogen atoms are more electronegative than the carbon they are attached to. This difference in electron activity pulls electron density away from carbon. Another way polarity can be seen or exercised is by looking at its solubility. Now, caffeine dissolves in water, proving it to be a polar molecule. Also, the solubility of caffeine provides the perfect example of how its structure provides the properties that make it useful in the function that it has in coffee and other foods and beverages. So that's a perfect example of how the polarity really affects what we use caffeine for. Now that we have looked at the properties and the atoms of the molecule, it is important to discuss the bonds of the caffeine molecule. As mentioned above, the letters H, C, N, and O all stand for atoms that make up the caffeine molecule. The second important point about this molecule is the lines that join the elements. Double lines represent double bonds. This means the two joined elements share 2 pairs of electrons. The sharing of 2 pairs of electrons means that there is a covalent bond between the two. So this here is a covalent bond. All these bonds are actually covalent. Intermolecular forces, covalent bonds make up the intermolecular forces of caffeine. On a side note, quickly, covalent bonds may be single, double, or triple bonds. One double bond in caffeine are the carbon and oxygen bonds. So here's an example there of a carbon and oxygen bond. These are called carbonyl bonds. Other double bonds are the carbon and carbon bonds. Here's an example of that. And the carbon-nitrogen bonds, which is known as an imine bond. So the carbon-nitrogen bonds, here is an example. So this is also known as a imine bond. Caffeine has dipole-dipole and dispersion forces for its intermolecular bonds. Now, the reason there are no hydrogen bonds present is due to hydrogen bonds being the electromagnetic interaction between polar molecules.